Materialise has been focused on applications of 3D printing all through its history. We see it as our mission to use 3D printing to create a better and healthier world, and by using 3D printing, not by developing 3D printers, but by linking the 3D printers that exist from all different brands through our 3D printing software with the different kinds of applications, both in the medical and in the industrial sectors. So when I started to prepare for this presentation, I started, well, looking at Wikipedia, what is a killer app, and then I got worried. Maybe I accepted too fast to speak here, because actually a killer app is a computer program that by its application makes the related hardware irrelevant. And good examples are, for instance, the well-known spreadsheet. A spreadsheet that meant, to some extent, a breakthrough of personal computers in many environments by giving people calculation possibilities and sensitivity analysis possibilities they had never had before in such an easy way. So the software was the product. And the software was the thing that delivered added value. Now, actually, in 3D printing is the other way around. It's not the software that is the killer app, but it's the product that is being printed that needs to be the killer app, or that needs to be a good product. And I hope that that is solving a little bit Jim's dilemma about the naming of killer apps. We shouldn't be talking about killer apps maybe in 3D printing, but about good, valuable products. And so that is also what we have been trying to do with Materialise all along our history, now 25 years. We have put the software in service of good applications where 3D printing really adds value. And 3D printing has a lot of technological assets to add this value. A first one, for instance, is the enormous design freedom, the enormous possibilities to create objects that couldn't be created with traditional technologies. Yeah. This is, for instance, one of the lamps that belongs to the MGX collection that we launched. It's the Quinn lamp by Bathsheba Grossman. And we believe this is really a good example of good use of 3D printing. That is, by the way, recognized by museums like MoMA or Centre Pompidou or many other design museums around the world who have purchased this lamp in their collections. But it is not just something that you can easily make. Yeah? Actually, in 3D printing, it's a lot about things you can print the next day, and that if you have an idea, you will have it tomorrow in your hand. And sorry, but I personally don't believe these are the value applications of 3D printing. These are the good applications of 3D printing. Because these are not the kind of products that will survive and that will enlighten people for many years. This lamp, for instance, took absolutely a year of development. Yeah? Bathsheba came up with the first idea as a mathematical artist. She had found a nice formula of self-intersecting surfaces that that can be created with 3D printing and not by any other technology. But that was far from a lamp. That was a nice shape to look at, but that didn't have the potential in itself to be a nice lamp. In order to create a nice lamp, we had to find solutions, and our engineers collaborated with Batsheba to find a good positioning of the light bulb in the lamp and to make that in such a way that it could be 3D printed as well, could easily be inserted, and the lamp could be replaced if it broke down, but at the same time that it was a safe lamp, that it was CE, in our case, CE compliant, that it was also a lamp that created a lot of value by being very nice and not a kind of lamp to look at, but also a lamp that generated light. So when I look around here, I see at the show a few lamps on booths, but mostly are illuminated objects. There are no lights. Yeah, they don't generate enough light to be a workable, to create a workable environment. This one does. At the same time, it creates a nice pattern on the wall. Yeah? In the Materialise building in Leuven, we have a few hundred of those lamps. And actually, we can afford to have them because they save us a lot of money in finishing the building. We just have a concrete building which is dressed by the light of those lamps with the patterns it's creating on the walls. Yeah? So it's creating a lot of value and saving cost while it's still an expensive lamp. So this, in my opinion, is one of the better examples of a value application of 3D printing. In a similar way, in the medical field, we use 3D printing for cases that can't be resolved by standard implants. This girl, for instance, is 16 years old. She had already her 4th hip implant, and due to some disease she had, little of her hip was remaining. So 3D printing allowed to change the design of the hip implant and to also design it in such a way that it not only supports her functionally, but that it also has the fine structures that allow bone ingrowth. The sad thing is that since that time, that girl has already broken her leg again. But on the other side of the hip implant, not this one, because this one is the first that really grows into the bone again, of all the entire series of implants. In the meantime, the other side has also been repaired, and she's walking and able to go to school again, thanks to this kind of hip implant. Yeah? And this is now being used. And that's why I believe, for instance, that orthopedics are one of the major good applications of 3D printing, where I personally believe that, in my opinion, and it's an estimate, up to 80% of all the orthopedic devices will be 3D printed in 20 years from now. But none of these devices will be exactly the same as the ones that are on the market with the technology of the past is not true, but of the conventional technology. Because it doesn't make sense to remake the existing devices with 3D printing. It only makes sense to switch to 3D printing if you increase the value of the device. If you, for instance, limit the amount of steps to manufacture the cup by immediately avoiding the spraying process of a coating for ingrowth, and by printing the background structure of the cup in biointegratable porous structures. And that's what's happening now already on a larger scale. Also for standard implants, there are 10,000 of people already implanted with 3D printed cups of this new design. Another example is this collapsible chair that is printed as one piece. This design from Patrick Join is also bought by many design museums because it's considered the first consumer product that really uses 3D printing in another dimension, not just the design complexity, but also the possibility to print directly assembly so that you avoid the assembly process afterwards. In order to do so, you have to come up with new concepts for the hinges, for instance. This little chair contains something like, I forgot it, but it's something like 45 or 52 or whatever, that kind of number of hinges. At the time we helped Patrick Join design this chair, we made them still relatively traditional. If you come along our booth, you will see how we design simple hinges today without the pin and dowel mechanism, so that there is no wear and that there is a better functionality in this kind of hinges. Yeah? By doing that, we avoid the assembly process of components, and we again have a good application of 3D printing because it's doing something that traditional technologies simply couldn't do, and where it's valuable to switch to 3D printing. Another example where Materialise has had a high involvement, because we were really at the basis of this development, is the use of 3D printing as a manufacturing method for hearing aids. Hearing aids can be 3D printed and have then advantages over the traditional manual way of making customized hearing aids. That was done by skilled craftsmen, but nevertheless they faced the limitations that each hearing aid was a kind of little piece of art with relatively little engineering. Today, the 3D printed hearing aids are engineered to fit the ear canal of every individual patient, to take into account that there is a tolerance so that they don't press in the ear, and that they nevertheless are better fixed than the previous hearing aids simply by the fact that they use zones where there is no bone in the nearby environment, because if you have an object impinging on your soft tissue, it doesn't hurt you. If that object is impinging so hard that it reaches your bone, you start feeling pain. Yeah? My wedding ring, for instance, is really cast in my soft tissue, and I don't feel anything about it. Yeah? I can't get it off anymore, but nevertheless, it doesn't hurt. Yeah? And that's happening with hearing aids now as well. Some people even forget to take them off at night, which is not desired, but they don't feel them anymore, which is a big difference with the hearing aids before they were 3D printed. And that was such a huge advantage for the hearing aid industry, such a quality improvement, that a company like Phonak switched already in 2006 from just making their high-end line of hearing aids with 3D printing to making all of their hearing aids with 3D printing. And today, our software ensures that more than 1 million people receive each year automatically designed hearing aids from Phonak. And each one is designed individually to fit an individual patient's anatomy. So here, we are using the possibilities of 3D printing to create individual products at the same cost as a small series of identical products. Yeah? Because these are really serious serial production at this moment, but each one is different. So I would like to repeat that we are not looking for killer apps, but that we are looking for products that use the technological advantages of 3D printing to really add value. Yeah? And I can testify this is even happening in my personal life. Yeah? I'm going to tell you a little, story. Even before I knew 3D printing, I was already involved in additive manufacturing. Actually, this little statue I made by an extrusion technology, extrusion of a tube of liquid metal that I gradually built up in 1986 as a first present for my girlfriend at that time for New Year, so 29 years ago. And I made this by really extruding liquid metal that afterwards was painted to give it a bronze look of her. She likes bird watching and her dog. And although probably from an artistic view it looks very nasty, it still sits in our kitchen. But it wasn't good enough. She decided to let me wait more than 2.5 years before willing to marry me, because of the poor quality, I assume. Yeah. But anyhow, and this was a doodler avant la lettre that was made by additive manufacturing. Today, through, for instance, Materialise, people have the opportunity to make gifts or to make awards for the ones they love or the ones they want to honor for an exceptional achievement or whatever by one of our apps or one of the companies that develops apps for Materialise called Twickit that enables you to make something customized, something personal, in a way that is also looking very professional and of a level that far exceeds my initial 1986 attempt. And it's accessible for many more persons, also the ones that are not that artistic as I was. Now, that shows how we can bring value by honoring people through making them dedicated objects of high quality. Another example that truly originated in the initial idea phase already in the 90s is the idea of 3D printing insoles. These are traditional insoles, and well, actually my children grew by the end of the 90s to 9-10 years of age, and all of them had to wear insoles. And I was highly frustrated by the fact that you go to, in Belgium you need to go to an orthopedic surgeon to prescribe insoles. That's already one stupid thing, but okay. And then the orthopedic surgeon sets on his prescription insoles. Yeah. In the best situation, he also measured a little bit the length between both legs, and he said 1 centimeter on the left, 0 centimeter on the right side, or whatever. But that's the prescription then a craftsman gets, who takes in a foam box where you have to put your foot inside, an impression that he uses to create along his own imagination and along his own skills a dedicated insole. Now, I would like to ask how many people in the room, if I'm not indiscreet, have ever been wearing insoles? If I may take a guess, approximately 20%. Yeah? So 20% of the people have probably gone through a similar process of having their foot measured some way, and then hand-made insoles, yeah? Of which we cannot really estimate what the effect is. Sometimes the medical world is rather a question of beliefs than of science, and this is definitely the case for insoles. So I started with first ideas about how can 3D printing help to create insoles and take more information into account than just the impression of the foot. Yeah? And actually, you start seeing people making 3D printed insoles, but most of them simply take a 3D scan of the foot. And what they are then doing is just repeating the foam box. Yeah? Even maybe a little bit worse than the foam box, because they scan the foot in an unloaded position. At least the foam box is giving you information about the foot in a loaded position. But always in a standing still position. And this is actually not what you want, because you want to walk with your shoes. You want to run with your running shoes. So, and the foot is constantly changing while you're making every step. The foot is rolling while you're making your moves. So the only way to make good insoles is to take the dynamic character of the foot into account. And Materialise was involved into orthotics since, I think, the year 2000 or so. And we have not come with a product to the market because we never found sufficient quality solutions for this problem. Until at a certain moment in one of our research projects, we started collaborating with a company that developed force plates and that really developed the technology to measure and analyze the gait while you walk or while you run over a plate. Yeah? And by the way, this company has grown quite famous in this gait analysis. They sold more than 8,000 of those plates all over the world already. And they are, for instance, analyzing of the Olympic teams of many countries to give the athletes the right footwear. Huh? It's a Belgian company, and even the athletic team of China flies into Belgium to come and to be analyzed to get the right shoes. And we then started collaborating with this company to redesign what we call dynamic insoles. These insoles, as you can see, are not full 3D printed, but they have, in fact, different structures integrated in different layers, so that while you walk, they act in a different way and they correct the behavior of the foot you have just seen along the line that you saw in the middle, and try to make that line as straight as possible. And that's the best way to assure we have scientifically measured with 3D imaging of moving measurements, that we in that way can adjust the gait and make sure that the knees get minimal load or equilibrated load. Yeah? This kind of insoles has been used over the past years by a famous athlete called Paula Radcliffe, who has been a world record holder and Olympic champion in marathon, but who had to abandon running because of problems with her feet. Now she is participating again soon in the London Marathon, thanks to this kind of soles that have made her feet again healthy. Yeah? Now, this application is one where we believe that with 3D printing we can do things that we can not do with any other manufacturing technology of soles. It's the first technology that really not only correct along the axis of the sole, but also correct for torsion in the foot movement during the rolling process. And actually that torsion is one of the major things that we measure to correct. We did a lot of effort to make sure that we didn't make the same mistake as the others making insoles, and that we really try to gather scientific evidence. Yeah? And actually, I don't think it's a coincidence that we came up at approximately 20% of the room that has been wearing insoles, because that's a little bit the worldwide average coming out of studies. Yeah? And we tried to find an environment where we could really prove the importance of this kind of insoles. And actually, that was a training program of, well, I don't know if it was the Royal Air Force or the Royal Navy in the UK, who participated in a study with 400 recruits, of which all of them were analyzed and categorized in groups that indicated that approximately 18.6% of them needed insoles or had deviating foot. Another 21% was on the borderline of needing insoles, and then 60% had healthy feet. Yeah? And after 7 weeks of intensive training, you could measure that the people with highly deviating feet had injuries for more than 50% of those group. So they lost training days because of the injuries in their legs. With the insoles, this could be reduced with 56%. Even in the second group of the medium affected people, there was a much higher injury rate that could be reduced with 30%. Yeah? And finally, in the last group, the amount of losses was low, and also the improvement was very little. Yeah? But this really shows in a controlled trial, scientifically set up, how this improves the way we are walking. So this is the result, again, of many years of development, but we make a product that really has good value, because it can help 20% of the world population. And we can scientifically prove that by 3D printing we can help 20% of the world population in having a better gait. What this means is in avoided implants and so on is hard to imagine. What this means in lost days of people not being able to work normally is hard to imagine, but it's enormous amounts. Another example of a good application that has emerged more prominently over the last year, but that was more than 10 years in the making, is the involvement of Materialise in heart surgery, in making models for children with seriously deviating hearts. This is just as a reminder for those who are not so familiar with structure of a heart, how a normal heart looks. Yeah? This is a normal heart. Now, look on the right side, or on the left side, sorry, yeah, from your perspective on the right side, at the little heart that the surgeon is handling there, yeah? That's how this baby's heart looked when he was born, yeah? Imagine what it means to try to make from this kind of structure, to take it apart and to re-sew it together in order to get a somewhat working heart again, yeah? Or a healthy working heart, or close to healthy working heart again, yeah? So it took us many years to develop the technology and to develop the software that we could imagine imaging such a small heart, that we could then, in the beating environment, create a stable analysis and make a stable model for the surgeon. Yeah? And still, this is a day of intensive work between the surgeon and our engineers every time again to make sure that we have the right anatomy, that out of the images we capture really what the surgeon is going to find. And then once we have captured it, he can start thinking about how his approach will be. In this particular child, he guaranteed that normally, if he would have done it the normal way, the child would have needed 3 open heart surgeries to come to an acceptable result. Now he got it in 1. Yeah? So this is a kind of applications again where a lot of added value can be created. So if the advantages and the potential to do good with 3D printing is so enormous, why is it so difficult? Why do we see, also at this show and at most shows I'm coming, that most of the prints, you see, actually I'm wondering again whether there are not more machines here than there are prints or demo models shown. And yeah, this is what makes 3D printing relevant, what you can print with it, yeah? And why so many of the objects we see are maybe nice for a few seconds, but don't last very long as a usable object. Yeah? So why is it so difficult? I think there are many reasons, and I will try to eliminate a few of them and on the basis of a case study. We started many years ago making drill guides for surgeons. And first of all, it's quite difficult to devise mechanical concepts that fits on everybody's needs based on the limited information you get from 3D imaging. And we had to do a lot of studies, purely mechanical. We have a special orthopedic lab at Materialise, an anatomical lab, in which we try a lot of different concepts before we even go to present them to surgeons. Took quite some time. Then, in 2007, we launched our first generation of knee guides after not only testing it in the lab, but also testing it with surgeons, testing it on cadavers, having it validated by multiple centers, not just one surgeon, but multiple. And we went to the market. And then this system changed the entire way for the surgeons of approaching their patients. It meant that they had to start planning the surgery not 5 minutes before the surgery by looking at the images, but yeah, a few weeks before surgery by interacting, if needed, with our engineers to define the ideal implant, the ideal position of the implant, and so on. So that was a big hurdle. Then they needed to learn to work with that guide, and that was not a hurdle because they've experienced that they could do their surgery much faster. So the investment they did before could easily pay off by actually reducing the amount of surgery time. But when we brought this product to the market with partners, 1 year later, all the competitors also had guides. So they did this entire development cycle, which took us many years, in just 1 year. Yeah? The consequence was when then surgeons and research groups started measuring whether guides were better than the traditional technology, that they came up with the conclusion they are not more accurate. Yeah? And yeah, you can easily imagine that when they try to compare the technology and not the different brands, that they came to the conclusion that on average, the guides didn't deliver any advantages. So by a lot of companies doing sloppy work, they started to maybe ruin a technology. Now, it were not only the companies who were making mistakes here, it were also the surgeons. Because in order to do this kind of surgery accurately, it's accepted that you have a kind of tolerance of plus or minus 3 degrees in the different planes where you cut. Yeah? And actually, when they measured, are my outcomes better with guides than without guides, they measured with tools that couldn't, that had a resolution that couldn't measure this 3 degrees quite accurately. So over the past few years, more than 50 studies have been scientifically published about the accuracy of guides. Yeah? And of those studies, not 2 have the same measurement protocol. And we can, with our engineers, easily indicate that of the more than 50 studies, approximately 50 have a measurement protocol that doesn't allow to measure up to 3 degrees of accuracy in general. Yeah? So what do we know at the moment? Not much. Yeah? There's one positive thing, this technology, I would not be telling this story because we would have to redraw it from the market if we could not be proud about the fact that our guides, we know, are more accurate. Because we have developed an entire measurement protocol that has taken us again a few years that we are trying to explain now to other groups to do the same kind of measurements to make sure that we were measuring accurately and that we are producing reliable results. Secondly, while those more than 50 studies cannot give a good answer on the accuracy question, what they scientifically demonstrate is that there is a serious economic gain. That actually all of their surgeons are able to do their surgery faster, which means less time that is spent in the operation theater, which means also a faster recovery for the patient, which means less cost for the hospital. And by the way, also the implant companies gain because they know beforehand better which sizes that they need to deliver to the surgical theater. So this application will not disappear because it has a serious economic benefit. But we haven't been able up to now to prove sufficiently certain the benefit for the patient. Yeah. So this is still ongoing work at this moment, even 8 years after the product has gone to the market. Yeah. So we believe that if we want to use 3D printing correctly, that when we do something, we have to do it right. And to use the quote of an American author, Hunter Thompson, anything worth doing is worth doing it right. So 3D printing should create products that are right. Now, I would like to say that it's our full belief that 3D printing has an enormous future, and that it has an enormous future for many sectors in which we are active. We truly believe that it's possible to make outstanding products with 3D printing. And if you also want to do that, then the question is, where should you start? Yeah? Where can you find today those highly valuable applications? And for that, we use the following reference frame. In the end, additive manufacturing is about building volume. So in the small product applications, it's the easiest to find high added value already of 3D printing today. That's why we call this our marble model. Everything with a volume that fits in a marble, like hearing aids, but like other sectors that have been already highly penetrated by 3D printing, the dental sector, the jewelry sector, their 3D printing is today already for a large amount of the products, the technology of choice. And this started already in the year 2000, as I explained earlier, that this was possible. Yeah? But since the year 2010, I would say, there has really been a big uptake in the orthopedic sector. The orthopedic sector is a typical sector where products have a kind of tennis ball kind of volume, yeah? Like hip implants, like knee implants. All those kind of applications are today really addressable by 3D printing if we look carefully for them and if we start with the highest values first. And in the following years, if we want to be looking at the future, we should start considering the football-sized kind of applications, because as the printing speeds will increase with new technologies delivered to the market, we will be able to do larger volume products. In fact, at Materialise, our industrial service organization has developed a kind of website where you can take your own product and where you can kind of get an indication about the printability of that product. From what moment on is a product eligible for 3D printing and can be a new design if you find some of the advantages like small series size, like complexity or whatever, or the possibility to integrate multiple components eligible for being manufactured by 3D printing, well, then you have to follow this kind of rules. It's a very simple algorithm. It takes the size into account. It takes the part complexity into account. It takes the value of the assembly or the part into account, series size, and then it will calculate a kind of indicator about the printability or the economic use of this application. This is where I would like to conclude. I want to repeat that, yeah, looking for the killer apps is for me not the best way to promote the use of 3D printing, to move in a healthy way forward with 3D printing. In the end, I would like to compare 3D printing more with the internet than with the computer age. In the internet, we have also seen that there are quite a number of applications that have grown very gradually, that were hyped maybe in the beginning, but that after 10 years had a very big impact. We have to look for the added value, and this is where we can really make a difference. By the way, making a difference is in making, is the name of an exhibition that Materialise is organizing in Brussels, where we will showcase extreme uses of additive manufacturing like this table, but also how value is being created. And if you want to learn more about it, I want to invite you to what we call our World Conference, where 3 years ago we had more than 600 people sharing interesting applications of 3D printing. I welcome you there all, and if you want to see some of the examples of our engineering, you can visit our booth at the Sant Expo. Thank you very much for your attention.